All right, guys. So here we go. We are tackling our first thing that's kind of new, but we've kind of tackled it before, and we'll kind of see. We got parametric functions, and so we're just going to do a little with parametric functions, and then we'll spend a couple of days working with these. So we are going to deal with the basic idea is what does the slope, what does the derivative tell us about a function? So we've got this idea that it tells us what the slope of the curve, and that doesn't change with parametric equations. We talk about the slope of the curve, that's still dy dx. And then the other one, yellow is a little irritating, and then the other one is our concavity. So our concavity is still the second derivative, d squared y over dx squared. And that all we have to do now is we need to figure out how to deal with this in terms of t. Okay? So we got to deal with it in terms of t. So that's kind of some of the problems you've been working on when it comes to the derivatives. So if we take this here and we break it up and we say dy dx, right? Well, when it comes to parametric equations, that is dy of dt, oops, that's a y, dy of dt over dx of dt. Okay? So we're going to take our first equation, and the example I have is if y is equal to 2 sine of t and x is equal to t squared minus 5. So here's my variables or my equations for the parametric equation. So dy of dt, I'm going to take the derivative of this one. So it's going to be y prime basically. So let me write it down here. So we'll do this. So I have y prime is equal to 2 cosine of t. So that means that the top of this is 2 cosine of t. So all I did was take the derivative of that. So then we need to do dx of dt, which is x with respect to t. And so that one, I'll do in a different color here, is purple. So dx of dt is equal to 2t. So we get 2t. So the 2's cancel, and we get dy of dx is equal to cosine of t over t. So now we have to work with the second derivative. So we have dy squared, d squared y, the second derivative of y with respect to x. Okay, so you have a formula that is looks a little different. And so basically what this is we're going to take the top part, we have to take the second derivative of y. So we need to take the derivative of y prime. And then we need to deal with the dx of dt. So dx of dt. Okay. So I've really got the idea that this is the second derivative. So I've got to take the derivative of this guy right here. Okay. I've got to take the derivative of that guy because that guy is y prime there. Okay. So remember that this is y prime. I know we have two y primes, so I wrote it here, but that's just for the top part. So now I have to take the derivative of that, which is a quotient rule. And so we have the derivative of the top, which is negative sine of t times t minus the derivative of the bottom, which is 1, times the top, cosine of t, all over the bottom squared. All over the derivative of dx dt, which is 2t. And so this gets cleaned up here. Oops. This whole thing actually goes down here. Sorry, guys. I messed these notes up completely. Okay. I'll just move it down there. So if we clean this up, we get the second derivative for this parametric function. I'm going to flip this over and multiply. I'm going to take out a negative, and I'm going to get t sine of t plus cosine of t all over 2t cubed. Okay? So that is the basic idea of the derivatives. Now, what messes everybody up is this part right here. It's really a formula piece that you need to look at, and I believe it's on page 540 something. 544. So this formula here is on page 544. Okay, so excuse me, guys, my neck hurts. So the idea is this. Let me see if I can explain this a little differently here. No, we can get into the theoretical reasons why this went. Oops, sorry. That this piece here is just dx of dt. And if you guys have questions about it tomorrow, I'll show you guys. So we can use the first derivative here to find the slope at any given point of this parametric equation, and we can use the second derivative by setting it equal to 0, and we can find our inflection points. So it's the same concept. We just got to deal with the formula that we're dealing with. Now, how do you find derivatives? Where are the derivatives horizontal and vertical? So you know that this one here is where dy dx equals 0, and this one here is where dy dx equals undefined. How do we find their locations? Don't we solve and then plug into the original, just like we did last year. Okay, that's original. Okay, so I'm going to go over a couple of quick things with you guys tomorrow in class, but that's the basic idea. And I'm going to go ahead and write down the formula for you guys. So here's your two formulas. This is the first derivative. First derivative, derivative is equal to derivative of y with respect to t over the derivative of x with respect to t. Okay? So that's how we find the first derivative. Now the second derivative is based on this formula. So this is the second derivative. I'm going to go ahead and write it out for you guys. So this is the second derivative. So the second derivative really, if we think about it, is the derivative of y prime. Now remember, this is y prime. And so it's the derivative of y prime. Right, so if we clean this up, we get this. And now remember, we got to deal with it with respect to t. So we get two different equations. We get the derivative of y prime with respect to t. That's this one. And then we get the derivative of x with respect to t. That's this one. That's why we don't really do anything different with that one, is because when we create the idea that we're doing it with respect to t, this is the formula we end up with. So hopefully that helps you out a little bit. All right, guys, we'll see you tomorrow, and good luck on this stuff here, and we'll get after it tomorrow.